Let's talk about calculating your required fall clearance distance. We'll begin by defining free fall. Free fall is the first factor in calculating your required fall clearance distance. Free fall is the distance you'll fall before your fall arrest system begins to slow you down. Properly designed fall arrest systems protect workers from contact with any lower level or obstruction, with no more than a 6-foot free fall. This is why the proper calculation of fall clearance distance from your anchor point is so important. Let's take a closer look at what we're talking about. If you're using a 6-foot lanyard connected to the dorsal D-ring of your body harness, and you connect the other end to an anchorage point at the same height, how far will you free fall? In this case, you'll free fall 6 feet, because that's the length of the lanyard that's connecting the 2 points together. However, how far will you free fall if you're connected to an I-beam 4 feet below your dorsal D-ring? In this case, you'll see a free fall of 10 feet. That's 4 feet to the I-beam, plus the 6 feet of lanyard. Here you will have exceeded the typical 6-foot free fall. Free fall is the first factor in calculating your required fall clearance distance. To determine if we have enough space below us, we must add our free fall plus our deceleration distance. Deceleration distance is defined as the distance it takes for the energy absorber to activate and slow your fall. The actual deceleration distance is based on the user's weight, the free fall distance, the type of lanyard used, and applicable standards. User instructions for energy-absorbing lanyards will provide deceleration distance charts to help determine specific system performance. Ideally, the maximum deceleration distance is factored in when determining the required fall clearance distance. Let's look at the following animation to illustrate fall distance closer. In this demonstration, a worker is connected to an overhead anchor point with a 6-foot lanyard. When the worker falls, the energy absorber on the lanyard activates, creating a deceleration distance of 4 feet. Regulations allow us to add 1 foot of deceleration distance for free falls over 6 feet up to 12 feet. For a person weighing over 310 pounds, specialized equipment is available to cover workers up to 420 pounds based on OSHA regulations. In Canada, regulations allow for up to 5.7 feet of deceleration distance when using a CSA-approved E6 compliant lanyard. At the onset of a fall, the worker's harness will shift slightly on the body, and the dorsal D-ring may slide upwards on the harness straps. This combination of movement is known as harness stretch. This factor, plus the worker's height, is typically measured at 6 feet. The safety factor is defined as the distance between the worker's feet and the level below at the instant the fall is arrested, prior to any bounce back. The typical distance is 1.5 feet. So in this demonstration, our required fall clearance distance is 17.5 feet, using a typical 6-foot lanyard with a 6-foot free fall. To reiterate, the required fall clearance is calculated by adding the length of the 6-foot lanyard to the 4-foot deceleration distance, plus the 6-foot height of the suspended worker, and the 1.5 foot safety factor.